When you watch a marathon, you're seeing a 26.2-mile test of pure human endurance. But the real race, the most critical one, is happening inside the runner's body. It's this hidden biological battle, a constant fight to maintain a razor-thin balance.
So picture this. A runner is in the final mile, they're giving it everything they've got, and then suddenly, they stumble, they get confused, and they collapse. Medics rush in, and what's the first thing everyone thinks? Dehydration. I mean, it makes sense, right? It seems like the only logical answer.
But what if that obvious answer is just wrong? What if the worst thing you could do for that runner is hand them a bottle of water? The real story behind this collapse is way more complex, and it pulls back the curtain on a fascinating life-or-death balancing act that's happening at a cellular level.
All right, so to really solve this mystery, we've got to understand the system the body uses to police its own internal environment. We need to meet the body's own internal detective.
And that system has a pretty sciencey name, osmoregulation. But don't let the big word fool you. The idea is actually pretty simple. It's just your body's way of actively managing its water levels, second by second, to keep everything in that perfect state of balance we call homeostasis.
Now, to keep that balance, your body is constantly checking its blood osmolality. That's really just a fancy way of saying how concentrated your blood is, stuff like salt. If the osmolality is high, your blood's too concentrated. You don't have enough water. But if it's low, your blood is too watery, and that, well, that creates a whole different and maybe even more immediate kind of danger.
So, let's start with the prime suspect, dehydration. Your body has this incredibly clever defense system, kind of like a standard procedure it runs flawlessly all day, every day to fight off water loss.
And you know, a marathon is the ultimate stress test for the system. A runner is sweating like crazy, losing huge amounts of fluid. And that sweat isn't just water, by the way. It's also full of crucial salts, electrolytes, especially sodium.
So the body's response is this beautiful, self-correcting loop. First, all that sweating makes the blood more concentrated. Then, tiny sensors in your brain's hypothalamus pick up on this change. In response, the brain releases a hormone called ADH. And finally, that hormone travels down to the kidneys with one very clear, very urgent command.
So how does this ADH actually work? Well, the full name, antidiuretic hormone, gives you a big clue. It literally works against losing water. It gets to the kidneys and tells them to insert these tiny little channels called aquaporins into the cell walls. You can think of them like emergency floodgates for water. With these aquaporin gates thrown open, water that was just about to be flushed out as urine gets pulled back, reabsorbed into the blood. The result? The body holds onto its precious water, and you end up producing just a little bit of dark, concentrated urine. The system works. Case closed, right?
Well, not so fast, because this is exactly where our investigation takes a huge, sharp turn. An action that seems totally logical, drinking water, can actually create a deluge of danger. This is where we get the big, unexpected twist.
And here it is. This is the question that blows the whole case wide open. What happens when a runner, who's just trying to do the right thing and stay hydrated, starts chugging gallon after gallon of plain water, without replacing any of those vital salts they've been sweating out for hours?
What they're doing is triggering a condition that sounds like it can't possibly be real, hyponatremia, or as it's more commonly known, water intoxication. Yes, you can literally poison yourself with too much water.
So here's the scene inside the body. The runner keeps drinking plain water, and the water level in their blood just surges. But since they aren't taking in any salt to balance it out, the sodium concentration absolutely plummets. The blood becomes dangerously diluted.
The consequences of this are, well, catastrophic. It all comes down to basic physics. Because the blood is now so much more watery than the fluid inside the body's cells, water rushes into the cells to try to even things out. This causes cells all over the body to swell up like little water balloons. But the most critical danger, the absolute worst-case scenario, is when this happens to the cells in your brain. That's a condition called cerebral edema.
Okay, so now we have our two competing theories on the table. Brutal dehydration on one side and this dangerous water intoxication on the other. Let's put the clues together and get to the final verdict on why our runner really collapsed.
When you put the symptoms side by side, the truth becomes pretty clear. Sure, severe dehydration will make you dizzy and tired, but hyponatremia? That causes confusion, disorientation, even seizures and a coma.
You see the difference? It's the profound neurological effects. That's the smoking gun.
And that leads us to our final verdict. The runner's intense confusion and the fact that they slipped into a coma, those aren't signs of just being thirsty. Those are the terrifying classic signs of a brain physically swelling against the inside of the skull. The diagnosis is hyponatremia.
So how do you prevent something this awful from happening? It's actually pretty simple. The risk of what's called exercise-associated hyponatremia is incredibly high if you're only drinking water. But if the fluid you're drinking also has electrolytes to replace what you're sweating out, that risk just plummets. So in the end, it's not about how much you drink, it's about what you drink.
And this really just brings it all back to that main idea. Homeostasis isn't some passive, relaxed state. It's a constant, active war your body is waging every single second. And during the incredible stress of something like a marathon, the stakes in that internal battle are quite literally life and death.
Osmoregulation is just one of these amazing, silent systems that keep you alive. And it leaves you wondering, doesn't it? What other invisible homeostatic battles, like regulating your body temperature or managing your blood sugar, are also being pushed to their absolute breaking point during these incredible feats of human endurance?